Hello and welcome to the latest edition of the Reimagine Mobility podcast series. I'm here with Gideon and very excited to talk about this field of mobility that he and his company are working in. So Gideon, thank you very much for joining us today. Maybe to start out with, introduce yourself to the listeners and the viewers, introduce your company, what you guys are doing, and then right after that, let's dive into the details here and how we together, from your perspective, see the mobility changing and reimagined going forward.
Thank you, Stefan. It's a pleasure to be here today with you. My name is Gideon Kedem. I'm the head of automotive business at Valens Semiconductor. Valens is an Israeli company based in Hod HaSharon, Israel. A little bit more than 250 employees, focusing on high-speed, high-bandwidth wired connectivity. We have two business units in Valens. One is focusing on audio-video. The second is on automotive. I'm heading the automotive business unit. Our core competency is a PHY. It's a digital PHY, delivering to our customer, as I said, high-speed, high-bandwidth connectivity, which is very essential for automobiles today. One of the key advantages of us being digital, our core technology is based on a digital DSP, which is giving our customer very high noise immunity and scalability for growth in the future. So that, I would say, in a nutshell, is Valens. We have field offices around the world, in Japan, in Korea, in China, in Europe, in the US, around all the major automotive hubs. And we have very good momentum with our new chipset family, which is compatible with the MIPI A-PHY standard.
As data and communication networks and the data transfer between all the different modules, independent if it's domain controllers or a distributed network, we have more and more technology, more and more controllers, more and more features in a vehicle. So obviously a very important thing that you guys are doing. Where do you see, or where have you seen over the last 2 to 3 years that the biggest growth for you is? Is it ADAS? Is it in the field of infotainment? Is it electrification that maybe some don't realize requires a lot of communication between different components as well? Is it generally the vehicle? Explain a little bit, where have you seen the growth and where do you see it happening in the next 3 to 5 years?
Well, I think all of what you've mentioned, right, is areas where there is tremendous changes and growth at the automotive industry. If we take a step back and we just think about the passenger vehicle as a whole, I think for many years the automotive industry and the passenger vehicle was a masterpiece of mechanical engineering, right? For many decades, automobile were masterpiece of mechanical engineering. And what we recently see happening, right, is a huge transformation that this masterpiece of mechanical engineering is actually transforming to a masterpiece of computer engineering, a masterpiece of computer engineering and artificial intelligence and robotics. It's an amazing change. It's opening huge opportunities for growth in many areas. The place where we are focusing on, as I said, is on connectivity, connecting all those new devices in this new vehicle, in this new software-defined vehicle of the future. Specifically, we are focusing on sensor-to-compute connectivity as part of the road to the automobile becoming an autonomous vehicle, right? Many sensors are deployed outside and inside the vehicle. You have a combination of cameras, radar, lidars, monitoring the environment, processing the data which is coming from the outside to enable ADAS systems supporting driver decision and in the future also full autonomous driving. But it's not only external, it's also internal. Following some regulation, but also requirement of customers. You have both driver monitoring system, also passenger monitoring system, new man-machine interfaces to activate the car, which is based on visual sensing of the movement of the passenger. So there's a lot of sensing which is done inside the car and outside the car. And we are focusing on the connectivity from those sensors to the central compute of the vehicle.
Right. Very, very critical for sure. I mean, I've been involved myself in many of those areas that you mentioned, from the sensors to the compute platform, for many years. And I've seen the amount of data that we're collecting is going up and up and up. And you mentioned AI, right? So we're essentially creating our own, so to speak, data lake in a central compute platform that then can be used for a variety of different functions, obviously. Gideon, explain maybe a little bit, what have you seen as it relates to the number of data, or the amount of data that's being distributed along the vehicle or communicated along the vehicle? In the past, we talked about kilobyte, then we talked about megabytes, then we talked about gigabytes. I think now we're probably talking about terabytes. Can you explain a little bit to that, how you have seen that progressing?
Yeah, and I think you have to look at that from several dimensions. One is the total amount of data, which is really becoming enormous, because the vehicle today is not just sensing the environment and doing the relative processing, and also sensing the near environment and the far environment, and also the inside of the car. There is also a lot of data which is being collected and monitored by the vehicle, right? If you talk to OEMs who are developing the software-defined vehicle of the future, and if you see and monitor what they do, they actually talk about the concept of a digital twin. So every vehicle which is actually moving on the ground, we have in the cloud an image, right, monitoring the behavior of the vehicle, monitoring the environment, and then implementing via over-the-air updates improvement to the behavior of this vehicle. We don't see that on the road today, but this is coming. But this is just another example of a huge amount of data that need to be transferred. If talking about where our company is focusing, again, I said we are focusing on the sensing, and the amount of data from our perspective is less relevant. What is important is the bandwidth which is required, which of course is related to the amount of data. But as you increase the number of sensors and as you increase the bandwidth, right, of those sensors, the connectivity becoming more and more challenging. So you see the transition from 2 to 3 megapixel cameras to 5 and 8 and 12 and 16, right? So you see the growth in this. You see the growth in the number of sensors. So we are talking to OEMs today about use cases, about architectures which are involving 16, sometimes 24 cameras per vehicle, and on top of that, radars and lidars. So the overall bandwidth that you need to transmit on the wires is growing exponentially. Today, cars who are on the road maybe need 1 to 2 gigabyte per second. We are talking now about 4, 8, 16, and even 32. So our car technology is supporting 8 gigabyte. We're talking about 16 gigabit in the next generation. This bandwidth is coming with, I would say, a lot of challenges and also limitation to how you can operate in the environment of the vehicle. So that I think there is a challenge with the amount of the data, but there is also a challenge with the bandwidth which is required to transfer this data over the cables.
Sure. That's very, very good distinction. I appreciate that. Absolutely. So you're saying you're looking already at 16 gigabyte, right, bandwidth. So where are we going to be in 5 years? Is there ever a point where we say we don't need more? Or are you foreseeing right now that as we continue to reimagine mobility and bring new technologies and features into the vehicle and make the truly software-defined vehicle a reality, is it ever going to end on how much bandwidth increases we need? Or are we going to change an architecture that we maybe do much more, again, go instead of to central computing, maybe change it again and go to more edge computing again to be able to limit that constant increase in bandwidth needs? What do you guys see there?
When we talk to customers, they are all talking about central compute, right? I think edge compute is something which is more expensive, not efficient, and also is causing a problem for, I would say, creating a reliable autonomous vehicle. You need to bring all the data into a single point and aggregate what you see around the car, right, to make decision. If you are relying on edge compute, eventually you are creating more latency, and you are also limiting the ability of the central compute to make the right decision. But there are also people who are looking into intermediate solution, because central compute have its own limitation, and I think we will end up with a hybrid model where the critical ADAS related data will all come to the central compute. The less critical data will be processed probably in a zonal controller, right? And then fed into the central. But definitely critical data moving to the central compute is something that we hear from all customers. Some of them would say, they believe in total central compute. Everything is going to central compute, and of course they will do it with redundancy. So you cannot rely just on a single element. They will do it with redundancy. But some of them are saying that they will do a hybrid, right, of a central and a zonal controller compute. But I think from you were asking about bandwidth, I think the increase in bandwidth for a single sensor is less dramatic and fast than the increase in bandwidth, which is impacted by the number of sensors, right? Because when you are, I would say, for the sensors today and tomorrow, 4 gigabit per second, 8 gigabit per second, even 12 might be sufficient for a single sensor. But then when you have multiple sensors and you want to aggregate them and you want to do it in an efficient way, you want to combine a few sensors into a single line. This is where the challenge is growing. But I think if you look into the next decade, probably 16 gigabit per second or maybe 32 gigabit per second, I don't think there will be requirements for higher bandwidth than this when you are talking about, right, sensor to compute connectivity.
So maybe shifting a little bit for a second, and over the years, I've been involved in electrical architecture development programs, in communication development programs, from the software stack to the integration to gateways, both to the cloud and internally to the vehicle, cybersecurity, and the discussion always came back and forth again. What are we going to use? What's the next version? Are we going to remain with CAN, right? Are we going to go CAN FD? Are we going to go to Flexray? Is it going to be Automotive Ethernet? And over the last 10 years, it was over and over again quite a bit of a discussion about it. Yet, generally speaking, I personally have seen only a few relative to the entire industry move away from CAN and go to either Flexray or Automotive Ethernet. You that work specifically in that space and work with all different types of OEMs, what do you see as it relates to that? What is the future choice of the CAN the communication protocol or physical layer protocol that's going to be used?
So I think that we will see in the vehicle moving forward an environment with multiple protocols, right? Because you need to design the car in an optimal way, right? So you will see CAN for certain things. You will see Automotive Ethernet for certain things, and you will see technologies like MIPI A-PHY, like Valence MIPI A-PHY, for the high speed, high bandwidth, what we call asymmetric link between sensor and central compute. The growing need for this sensor connectivity was actually the main motivation behind the definition of the MIPI A-PHY standard, because the protocol that you have mentioned, right, they do not answer the requirement of those type of links in an optimal way. One of the aspects that I think people are not still fully internalizing and understanding is the tremendous growth or the exponential growth in noise immunity challenges and EMC and EMI challenges, right? Because today most of the vehicles are still using relatively low bandwidth, 1 to 2 gigabit per second. If you are looking into the cars that should leave the production line in 25, 26 with multiple sensors with 4 gigabit per second, 8 gigabit per second bandwidth links, then the sensitivity to noise, the sensitivity to EMI and EMC interference is becoming very, very critical. We have designed our devices, right, and the MIPI A-PHY specification are addressing the next generation challenges of EMC and EMI. One of the things that we have implemented very successfully is a connectivity based on a digital PHY. A digital PHY with a DSP core inside is enabling you to implement mechanism like noise cancellation, like retransmit at the PHY level, right? And those are actually enabling overcoming very severe EMC environment. Because, today in the vehicle, with the tremendous growth of electronic components and the bandwidth and the speed, the noise which has been created inside the car is much more significant than in the past. The vehicle is also exposed to strong noise coming from the outside, cellular antennas, radar outside, right? Other cars near. So it's the environment is becoming much more challenging. And I think one of the things that we are also asking customer to consider is the way they test for EMC immunity. Many of the tests and the standards today are very appropriate for the past, but not for the future, right? The tests that are done today are done for cables which are relatively short, 2 meters of a cable, for cables which are not taking into account the impact of aging. So if you test today, if you want to put element into a vehicle today, and you test it with a cable in the length of 2 meters, and you are using a new cable, right? And then you put it in the car, and actually the cable which is connected to the system is 10 or 15 meters at length. And with time, the cable is aging, you end up with a problem. You may have problem in the field 2-3 years after the vehicle have left the production line. I think that we are building our technology and we are testing our technology for much longer cable situation than the standard. We are also building it and testing it to be able to overcome the challenge of the cable aging issue, right? And when we compare it to competitive technology, we see huge differences. And I think we are in the process of educating the market. Hey, it's great that everybody are moving up the scale. You put many sensors, you take higher bandwidth, everything is going faster, but what about your noise immunity? What about the EMC sensitivity? Are you sure you have checked it? And don't check it for the situation which is now in the lab. Check it for the environment that the car will need to face 2-3 years after it left the production line. It's a process we are going through, and I think that we see the future in a very clear way, and we are trying to share that with our customers.
That's very good. No, I completely agree with you. I think EMC, EMI in the 25 years I've been in the industry has consistently increased in importance, and increasingly also increased in the challenge that it poses to the OEM and the end product, right? To really have a product that is protected against it at least, or limited its impact of it to the product because of all the different components and different features and functions we've brought into the vehicles. They're absolutely right. So maybe with that question, we've talked now, I think, maybe mainly passenger vehicles, and you talked about cable lengths of 15 meters or longer. So I'm thinking now autonomous trucks that are at least in the US, as well as to some degree in Europe as well, really looked at maybe the lead, right? The trailblazers, so to speak, as it relates to level 4 or level 5 autonomy for good deliveries. So specifically to you, I assume you guys are working with heavy-duty truck manufacturers as well. Look at again the bandwidth challenges we have there. Well, we maybe even need more sensors to have a level 4, level 5 heavy-duty truck to drive and deliver goods. So how long do you think with your technology can these wires be? Because we may need sensors that are in the back of the trailer that is way more than 15 meters. So what do you guys see there, or how are some of those challenges overcome in that space?
Yeah, so I think what you're raising is a very good and valid point, and we do have some interesting activities in this area. I must say, you started the discussion asking me about the growth potential, etc. The passenger vehicle is a much larger market. The growth potential there is huge, and I think also the focus and the interest of the, I would say, the industry is much more on the passenger vehicle than on the heavy trucks, etc. But there's definitely a very growing and demanding market for what we call the commercial vehicle. And there are many challenges in this commercial vehicle. You mentioned a few of them. It's not just for the autonomous car, also for the autonomous trucks. Also, if you look today into regular trucks, right, it's usually a combination of a truck and trailer, and in the different fleets, they want to disconnect and mix and match trailer and truck. They take a trailer to a certain location, then they disconnect and connect to another one. And all of those trucks today, or most of them, don't have rear view cameras, because of the combination of the challenge of the length, but also the need to be able to disconnect and connect in a fluid way. We are working with a partner in the US, a company by name of Stoneridge, and we're actually rolling out to the market a solution for this challenge. This is something that is unique to us and Stoneridge, and only with our technology you can actually overcome those two challenges. But also looking into the future, what you have mentioned, we are already qualifying our new product or family that we have first rolled out into the passenger vehicle market. We're already qualifying it for lengths of 40 meters and even a bit above, right? To address exactly what you've said, right? Because in those commercial vehicle market, you must have a solution that can sustain the signals, overcome the interference over a much longer distance, right? So we are already qualifying this. We are working with a few leading truck vendors, but I think in this market things are moving a little bit slower, right? And the market in general is a bit slow. So definitely we have focus on that. We have some things happening there, but our main focus is on the passenger vehicle market.
Oh, very good, very good. So maybe the last question then, not going to ask you when you believe the true mass deployment of level 5 vehicles for autonomous driving will happen, but maybe I'm going to ask you a slightly different question. You talked a lot about central compute platform, and I know a lot of OEMs, or most OEMs, are looking into that, maybe even working on it. When do we start seeing mass deployment of vehicles that are truly having a central compute platform?
27, 28, right? SOP 27, 28 is where you will see this thing happening in a larger scale. You'll see some of it already happening in 25, 26, but I think 27, 28 is more the mass product. And when you go around the world, right, in different territories, things happen in a different pace. If you go to China, and I've been to China a couple of months ago, it's amazing, right? The path and how quickly they do things, not always successfully, right? But they move really fast because they are trying to get ahead of the pack, right? If you talk to the traditional OEMs like the Japanese or the European traditional OEMs, they move a bit slower. Doesn't mean that the Chinese will actually beat them, right? They may end up being first because of their capability and I would say in heritage and also experience. But this is why I say it's not that all OEMs will be there at the same time. Some OEMs are already doing that today, right? And rolling up car with central compute. But I think you will see this coming in a very significant way from an industry perspective, 27, 28.
Okay. Very interesting. Thank you very much, Gideon. Very, very interesting topic and very relevant to where we're going with advanced levels of ADAS or, again, level 4, level 5 autonomy going forward. And, again, communication and data more and more important than it ever was in a vehicle today. So thank you very much for your insight and helping us reimagine mobility together here. Thank you.
Thank you for watching this clip of Reimagine Mobility Podcast. To see the entire episode and more, check out the links in the description.